Okay, I'm back to do time zone A and B's HL paper 2 for analysis and approaches. So if you watch the video for the paper 1, normally I skip SL questions, but I only have the HL paper, so I don't have an SL paper that I had went through in a previous video, so I gotta go through the whole thing. That means that this video might be a little bit longer, which I don't want it to be, so I'm gonna try to speed through it, and maybe that means I'll make more mistakes. But anyways, this is question 1. This looks like a straightforward linear regression. So I'm just gonna input my numbers into my calculator. And then we're gonna do a linear regression. And make sure you read the question. For time zone C, they actually had I would say a fairly unconventional linear regression question that I messed up because I didn't read properly. But for this one, we're regressing H on D. So just make sure that your independent variable, your X list, is the list with D, and Y is the other one. So there's your A and B, 193, 721. Okay, and then we are going to estimate the average height of the person if the experiment's gone for 20 days. So we just make our find our H value when the D value is 20. So now that we have a linear regression formula, you can just slap it in. So 45.81. So 45.8, whatever this is, centimeters, doesn't matter. Okay, next one. Looks like trigonometry. Okay. Blah 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 blah. Okay, you have all of this. 150, 90. Find this height. Okay. So to find that height, it's part of this right triangle, so I need to find this angle. This angle is connected to these 3 angles, and then so we know that that should be 180 together. And because these are the same, if I find out this one, I can figure out what theta will be, and that angle is part of this non-right triangle, which we have the 3 sides for, so we can use cosine law to figure it out. So if I call this, I don't know, whatever, I'll just call it C, then cosine C is equal to A squared plus B squared minus C squared divided by 2AB. Okay, so clear this out. So we have 150 squared plus 90 squared minus 154 squared. Okay, and then we're gonna divide that by 2 times 150 times 90. Okay, and then this is cosine C, so then now we're going to take the inverse, and it doesn't ultimately matter which mode you're in terms of degrees or radians, because we're gonna, I think I'm in radians, because we're gonna put this all in the calculator anyways. Okay, so I inverse cosine that. So then this is 1.3 something radians. Okay, so then that means that these three angles will be adding to pi instead. So theta is going to be pi minus 1.31, and then you divide this by 2. Okay, so take this, subtract it from pi, divide by 2, you'll get 0.914 radians for theta. Okay, and then now that that's done, we can just use simple right angle trig, because this is 150. So then h is 150 times sine theta. So now we take, well, first I need to make this not negative. Okay, take the sine of this, multiply it by 150, and then we're done. 119. Okay. These first ones shouldn't be that bad because, the SL questions are usually like the first 4 or 5. Okay, this one looks like distribution, normal distribution, maybe binomial theorem afterwards. Okay, the weight of grams, normal, mean of 204, standard deviation of 5. So I like to draw these things out. So 204, and then we're gonna select a bag at random, find the probability that it weighs more than 210 grams. Okay. Okay. So this is just so probability that the weight is more than 210. Okay, use your calculator, because you have the mean and the standard deviation, so we can just go into our distributions and then do a normal CDF. And our lower boundary is 210. We don't really have an upper boundary, so in this case, my calculator, I just need to put in an appropriately large number. The mean was 204, standard deviation was 5. Okay, and then there you go, 115. Okay, and then 80% of the bags weigh between W and 210 grams. Find the probability that a randomly selected bag of rice weighs less than W grams. Okay, so we're just gonna sketch out this information. So 210, I know from part A that this right here is 11.5%, and then it's saying that between W and 210, so I'm just gonna draw W over here somewhere. They're saying that this is 80. Okay, and then essentially we need to find out what this boundary is. So we're going to be using inverse normal, and depending on your calculator, you may or may not need to find different tails or areas. So I think in mine, when I use inverse normal, yeah, mine only will accept the left area, this area here. So that's easy to figure out though, because the whole area is 100, and you know that these two parts are these percentages. I wonder if I can do this in my head. Okay, so then that means that this part right here is like the rest of the percentage that makes 100. So what is this, 91.5? So this needs to be 8.5%. So 0.0. Okay, here. Why don't I just do it like this? 1 minus 0.8 minus 0.115. Okay, 204. 5. Paste. Okay, 197 according to this. Oh, I didn't even read the question. I did B and C in one thing. Find the probability that a bag of rice weighs less than that. Well, that's what I did right here. And then you gotta find the value of W, which I did right there. Okay, and then, aha. See, I knew it. These normal distribution questions always turn into binomial distribution. So now you have 10 independent rice bags, and then you need to find the probability that exactly one of them weighs W grams, right? So now we're turning this into a binomial distribution. We need to find the probability, oops, not 4, that exactly one of them weighs less than W grams. So now we go into binomial PDF, 10 bags. The probability of being, what was it, less than W or more? Less than W, that's 8% or whatever. I'll just write it like this because I don't trust my mental math right now. And then 1 bag, right? So 38.2% or 382. Okay, that one kind of took a little longer than I wanted it to. Okay, looks like we have some binomial theorem. So if you expand this out, you'll get this, of course, and then some A, B, and D are geometric. Then we need to find the value of H. Okay. Okay, so according to binomial expansion theorem, actually, let me do this. Is this going to be quick? I'm going to cheat a little bit to save myself some time. But I need the 8th row of Pascal's triangle. Because I do need to expand out the entire thing. We're not just looking for a specific term. So, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8. This one. I think. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. So, I mean, it's 7 marks. You could have spent, you know, a minute or two making the triangle. And then from here, we can write out the full expansion. So this is going to be 1x to the power of 8 plus 8x to the power of 7, h to the power of 1 plus 28, x to the power of 6, h to the power of 2 plus, and then so on. So x to the power of 5, h to the power of 3, and then I'm gonna stop once I get to the term that should have d in it, just to save myself some time. 70x to the power of 6, or wait, no, this one goes down, and then h to the power of 4. Okay. So they're saying that A, B, and D are geometric. So the coefficient A would be 8 and H, B would be 28 and H, and then D would be 70, and then h to the power 4. So now we know that 8h, 28h squared, and 70h to the power of 4, this is a geometric sequence. Which means that they have a common ratio. So if I take the second term and I divide it by the first term, and then this will simplify into something. No, these are both divisible by 4. What's 28 divided by 4? God. Seven. Okay, this is going to reduce to 7 over 2h. And then likewise, we can also divide the third and second term, which would also result in the common ratio, and then this one would reduce to h squared, and then whatever 70 over 28 is. 70 divisible by 14? Yeah, okay, so 5 over 2. Okay, so this is u2 divided by u1. This one's u3 divided by u2. Okay, and then after we simplify, we have an equation, and then we can solve for h. So I'm going to move the 7 over 2h over and factor out the h. And actually, I'll factor out the 1/2 too. Okay, so I did a couple of things here. Hopefully you can follow along as HL students, although this is an SL question, right? Move this over here and then factor out the 1 over 2 and then the h that they both have. Okay, so this means that h could be 0 or it could be 7 over 5, and I'm pretty sure h can't be 0. Yeah, because it's a positive integer, or not integer, rational number. Here it is, 7 over 5. A little tricky, a little tricky. Okay, here is your classic kinematics question, looks like. Okay, blah 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 blah, velocity here. This is a velocity graph. T1 is the time when the acceleration is 0. So essentially we are figuring out when the derivative is equal to 0. Okay, so you take the derivative of this and then we're gonna graph it. So I'll just derive it for you instead of cheating, which I'm gonna do in just a split second after I do this. Okay, there's a product rule here. So v prime of t is going to be -4 over 3e to the negative t over 3 times cosine t over 2 minus pi over 4. So that's the derivative of this one with a little chain rule, and then we add that to the derivative of the cosine part, which is gonna be this. Right, so derivative of cosine is a negative. You get the sine. There's a chain rule with a 1/2, which goes there. Yeah, I could write that as a 2, but whatever. Okay, and then basically we solve by GDC. So you can find the x-intercept, you can put into the equation solver, whatever. Okay, I'm gonna go to Desmos, which is basically just a more efficient graphing calculator. And hold on, let me just type in my velocity function first. 4e to the power of negative x over 3 times cosine x over 2 minus pi over 4. And then this is from 0 to 4 pi. Okay, so here's my graph. And then make sure you're in radian mode because we're working with pi. And then, so Desmos can do this. I can just be like, oh, just graph me the derivative of v. So here's the derivative of v, but that's why I showed you this derivative, because you would just put this into your graphing calculator instead. And we want to find out when this is first time being 0, which is right here. So this is the time, 395. Okay, then we need to find the second time that the particle is instantaneously at rest. So this is when the actual function is equal to 0 here. Okay, and then, well, here's the actual function, and the second time it's at rest would be this one right here, 7 pi over 2. So your calculator would probably give that as a decimal number. So I know it's been a while since you guys wrote this, so probably don't remember your numbers. But in the off chance that you do, I got 10.99, basically 11. The first time and the second time, right? First time the acceleration is 0 is right here. Hold on, let me just double check my work. I don't want to go this far and mess up my numbers. Sure, whatever. Okay, and then we need to find the distance traveled between T1 and T2. Okay, so this is the integral from T1 to T2, and we're gonna double check something, and that is T1 is here, and then T2 is here. So T1 is here, and then T2 is here. So as you can see, there's going to be some area or distance that will be positive displacement, and then there's going to be some that are negative displacement. So you can't just integrate straight from T1 to T2. You will need to take the absolute value to find the total distance traveled. Okay, so we're going to do that integral, and then what was it? 0.39 something. 5, and then this is 7 pi over 2, and then this is the absolute value, and then all of this is doable in your graphing calculator. I'm just using Desmos because it's a little faster, and there you go, 7.83. Okay, and then I think that is the end of the SL questions, because I see planes and vectors in the next one. How am I doing for time? 24? With an av... I'm not that fast right now. Okay. Okay, line of intersection between these two planes. Verify that this vector equation L... Okay, this vector equation is the line of intersection. Okay, so if you're verifying, you don't need to like go through all the typical math to figure it out, the equation of the line, because you have it. You can just see if it satisfies both of these equations. So R, which is essentially a position vector of any coordinate on the line, is made by having this. So I'm gonna write it together as 0 plus lambda times 1, which is lambda, and then 2 minus lambda times 2, so 2 lambda, and then 4 plus lambda times negative 2, so 4 minus 2 lambda. So I'm just combining these together. Okay, so this is x, y, and z, and then if you want to confirm that this is the line of intersection, you need to confirm that this coordinate will always satisfy both equations of the planes. So for plane 1, so 2 times the x, which is lambda, minus y, which is 2 minus 2 lambda, plus 2 times z, 4 minus 2 lambda. Okay, and then if you simplify this, it should equal to 6. So goodbye 2 lambda. Wait, hold on. Okay, so this makes 4 lambda. That's going to cancel with that one. So you get negative 2 minus 8. Yeah, so then this is equal to 6. Okay, so this is good. This means that L is in the first one. And then we check the second one. 4 lambda plus 3, 2 minus 2 lambda minus z. Here, and then this should equal to 2, which it probably does. Okay, and then, you know, go look around. So these lambdas cancel out, and then you have 6 minus 4, which is 2. Yeah. Okay, so therefore L is the line of intersection between the two planes. Easy. And then find the coordinates of the point P on L that is nearest to the origin. Okay. So for part B, oh, when did I switch to green? For part B, we need the distance from the origin to point P to be minimized, right? Okay, so that's easy enough. Basically, you know that the position vector for P, which is also the same as OP, is just the coordinates of point P. Point P is any point on the line, so we're just going to use these as x, y, and z. Okay, so then your distance is whatever. I'm gonna square the distance so that I don't have a square root in my function. So squared plus squared, and then plus squared. And the reason why I do this is because it's easier to take this derivative, slightly easier than the one with a square root in it. And if you minimize the distance squared, you will minimize the actual distance as well. So So this isn't implicit differentiation or anything, right? We're just taking the derivative of this side. So then this is 2 lambda, and we're solving it for when it's equal to 0. We're minimizing the distance squared. And then, do I really want to do this? Hold on, let me expand this out. You know what? I'm going to simplify this first before I take the derivative. Easier to take derivative of polynomials than anything else, really. So 4 minus 8 lambda plus 4 lambda squared plus 16 minus 16 plus 4 lambda squared. Okay, you don't have to do this, and I don't know if this will be faster than if you had just done other things and shoved it into a calculator. But you know what? I don't like using the calculator more than I have to. But that's just a personal thing of mine. 20? Oh, I thought this would be factorable. Maybe it is, but I don't know. Did I do this right? 4, 8, 4, 16, 8, 16, 4, 4, 4, 1, 9, 4, 16, 20, negative 8, negative 16, negative 24. Okay, whatever. Okay. And then we take the derivative. So this is going to become 18 theta. Actually, we didn't even need it to be factorable because I need to take the derivative. 24 over 18. And then what is this, 4 over 3 or something? Okay, lambda's 4 over 3. And then again, we're equating this to be 0 because we're optimizing. And then we want the coordinates of point P. So we just found out lambda, then we put it into here. So I'll just write it here. P has the coordinates 4 over 3. 2 minus 2 times 4 over 3. Oh my god, I don't want to do this stupid fraction math. Okay, what's 2? 6, right? 6 minus 8 is negative 2 over 3. And then 12 minus 8 is also 4 over 3. Sure, okay, whatever. Just plug this in here and then do the math and you'll get something. That might not be right. Okay, next up is a volume of rotation. Solid of whatever. Okay, you have a graph, it's arctan, minus 2, okay, fancy, whatever. And then you're going to rotate around the y-axis. Okay, first off, just so that you have a visual of what arctan looks like. And then, I think it was minus 2, right? And it is from 2 to some number up ahead. So if you look at the graph, here is 2, and then it stops like somewhere over here. What was it? 2 plus root 3? Yeah, okay. So we're taking this little thing and then we're rotating it around the x-axis, or sorry, y-axis. Boop, 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 boop. And then we want to find the volume of this. Oh, wait, this line, hold on. Between the x-axis and that. Okay, I think if you put in pi over 3 as x, you will get this y value or x value here. If you put in y, yeah, okay. So this probably corresponds to a y value of pi over 3. Otherwise this doesn't make sense. Yeah. Okay. Sorry, that's just me double checking. Anyways, we want to find the volume of this. There's a formula, just use it. So this is an integration from, in terms of y though, from 0 to pi over 3. Okay, so it's going to be pi, and then you need the function of an inverse. So we need to find the inverse function. And then that's easy enough to do because this is arctan. So y equals arctan x plus 2, which means that x is going to be tan of y plus 2. Okay. Tan of y plus 2 squared dy. Okay, and then this you can just put into your graphing calculator because it's a definite integral. So again, I'm just going to use Desmos. So 0 to pi over 3, and then it was pi, and then tan, and then I'm using x as my variable just because it's Desmos, plus 2 to the power of 2 dx. Okay, 24. Okay. Question 8. So I should be almost at the long questions. This looks like a rational function type thing, but we'll see. How am I doing for time? Almost 40 minutes. But then 7 times 6 is something. I thought it would be a little faster. Okay. Okay, function g is determined by this. Determine the range of g. Okay, so you should graph this because you have a graphing calculator. 2x minus 5, and then what is it? X squared minus 3. 2x minus 5, x squared minus 3. Okay, so we want to find the range. So because the degree of the denominator is larger than the degree of the numerator, we do know that we have a horizontal asymptote at 0. And then as you can see, there is some values of y that it will not be as well, aside from 0. And that is, then you'll need to use your graphing calculator to find this minimum value and also this maximum value. So your y does not look like it can be between this one and this one either. So 232 and 143. 232, 143. 232. 143. Okay, so y cannot be 0. And then also y has to be greater than this value or less than this value. Yeah. Okay, then we have a function h, which is g, this g, and then you do an absolute value transformation of x, and then you multiply by cosine t, and then t is just some number, but t is always between here. Find the set of values x so that this is always negative. Okay. Okay, so we're multiplying by some number, cosine t, and then t is in the second quadrant, which essentially means that cosine t is always negative. So if cosine t is always negative, and we're trying to find out when h is negative, and h is this g times cosine, then essentially we are more or less gonna find out when is this positive. Because you need this to be positive, because you know this is negative, so they need to multiply together and make this a negative result. Okay, so we know what g is, and then you need to know what this transformation does. This basically takes the positive x side of the graph, and then it reflects it across the y-axis, making it why is this here? Making it an even function. So you can see that just by, you don't need a graphing calculator for this, but I'm just showing you. So y equals g of absolute value x. So you see it takes this side and then it reflects it over. But you don't need to see that, because again, you're more or less just finding out when this side is going to be positive y values, and then also remembering that the negative side version of that will also be an option. Okay, so when is g positive? So have positive y values, or 0. So 2.5, 2.5 and onward, and then between the two vertical asymptotes, which were plus or minus square root 3. But of course, we're only looking at this. So again, g of x is going to be positive or 0, where from 0 to square root 3, and then or which cannot be equal to square root 3, and then 2.5 onward. But then, you know, so then this is what I just drew here, like this, and then that. And then when you take the absolute value, it would be reflected this way, and then that way. So now your intervals change. So it's between negative square root 3 and square root 3, and also now on top of being greater than 2.5, it could also be less than or equal to negative 2.5. So hopefully that makes sense, what I just did. But I need to speed along because I'm not even at the long questions yet. Uh-oh. And this one does not look good. Okay. I'm going to tell you guys now, I am really bad with combination questions, combinatorics questions. And this one looks really bad because you have 30 integers, you randomly select 3, and then you add them together. And you need to find the probability that when you add them together, find the different number of ways that you can get something that's divisible by 3 when you add them together. And this is only 5 marks. Okay, let's see. Well, you could add like the multiples of 3 together. So how many multiples of 3 are there in... There should be 10, right? From 1 to 30. So you could select any of these ones. So these are multiples of 3 added, and that'll always be divisible by 3. But then there's so many ways that you could do this. Because like you could add like 1 and 2 and 3. And then you could also do like 1 and 2 and 6. And 1 and 2 and 9. Oh, I don't want to struggle on camera. You know what? Here. This is some trick that I learned. Instead of... I'm going to see if there's a pattern. And what I'm going to do is I'm going to... 5, 6, 7, 8, 9, 10. And what I'm going to do is... I'm going to use a smaller example so that there's less combinations that I have to worry about. So I could do 3 plus 6 plus 9. So those are my multiples of 3, right? I could do 1 plus 2 plus 3. I could do 1 plus 2 plus 6. 1 plus 2 plus 9. And then this was something that I was thinking about as I was going through it earlier. This one's always a multiple of 3. And then I could do like 1 plus 3 is 4. And I need to be a multiple of 3, right? So I could do 1, 2, 3. So 4. This makes 6. So it needs to be 9. Huh? 5? I'm sorry, my math was slow there. Because then 1 plus 5 plus 3 is 9. And then 1 plus 3 is 4. And then I could add 8 to make 12. I can also add even numbers together. Like, what about 2 plus 4? 2 plus 4 is 6, and then I could add 3 to that. And then, what about like 1 plus 2? One plus 4 plus 7 works, right? That's 12. Yeah. 5. This could be 4, right? Yeah. I think I spent too long on this question. But I don't really know how to do it right now. Should I start with an even smaller group of numbers? Like 1 to 6? Brutal. Wait, is 3 number? It needs to go to at least 9. So that I can select 3 multiples of 3. Then it's not really that much different than 10, right? Okay, if you select 2 multiples of 3, then the third one has to be a multiple of 3. So let's say that you select a multiple of 3, for example, 3. It doesn't have to be 3. Then what do your other 2 numbers need to be? You could have 2 and 1, right? If you keep the 2, that's 5, and then the next multiple would be 4. Next multiple would be 9, so that needs to be 4. And then 3 plus 2 is 5. And then 5 plus something is 12. You could also do 7. And then there's a pattern of adding 3 here, which makes sense. Because if you just add 3, you'd still have a multiple of 3. And then I could also add 3 to the 2's until I'm at the end. Okay, and then what happens if I don't select a multiple of 3 as one of the numbers? So let's say like 1. And I cannot use multiples of 3. That means that I can't use 2, right? Because 2 means that the next number has to be a multiple of 3. And I can't use a multiple of 3, so that means that I have to keep using basically something that is 3, a multiple of 3 away from 1. So like 1, 4, and 8, right? Or 7. Okay. And then if I choose 2, plus 1 is 3. Okay. This took me way too long. I think I kind of get it. Okay, you can have all multiples of 3, so 10C3. Or you could have a multiple of 3 plus a number that's like a multiple of 3 away from 1. So like 1, 4, 7, 10. So there should be 10 of those, right? So a multiple of 3, there's 10 multiples of 3. There should be, starting from 1, I think 10 numbers that are starting from 1, and then if you add 3, like geometric sequence, there should be 10, or sorry, arithmetic sequence to 30. And then also you could have 2, and then any number that is like again 3 away from 2, which I think there's 10. And then there's the last one, which is if you don't have any multiples of 3, then your 3 numbers have to be part of this one, these numbers, which start at 1. I'm probably not explaining this right, and there's probably like a more like whatever way of describing this, but I've already spent like 3 times the amount of time on this question than I should have. Maybe it's this? Whatever. Like I said, I'm bad at combinatoric stuff, and I'm not even on the long questions yet, and I spent way too long on that. Okay. Spring goes up and down. Periodic function. Find the period of the function. So the period is going to be 2 pi divided by your horizontal stretch or compression of 7.8. So punch this into a calculator. Pi divided by 7.8. So your period is 0.806. And then the thingy is 1 meter off the ground. It goes up to 1.8, and then we'll probably need to find out the rest of the coefficients, right? So before we do that, if you are between 1 and 1.8, then we need to find what I call the midline of the wave. So we can just add the minimum and maximum values together and divide by 2. So 1.4. Good enough. Okay, and then from there we can find the amplitude of the wave, because since the minimum is 1, then my amplitude is 0.4, and then this is my midline. Okay, and then find the value of A and B. So A is here, and then B is here. So B is a translation up and down, so that is going to correspond to where my midline is. And then A has the value of 0.4, but it may be negative 0.4 depending on what the function is. So in this case, it's a cosine function, and notice that we start at the minimum value, which is a negative cosine graph. So A should be negative 0.4. Okay, find the number of times that the weight reaches its maximum height in the first 5 seconds of its motion. Okay, so we know that in 0.8 seconds we have a complete period, which means that it reaches the maximum once. So we just need to take 5 seconds and divide by our period, and then we round down to 6 times. And then find the first time that the base of the weight reaches a height of 1.5 meters. So now that we have our function, we can just solve this equation or graph it. So negative 0.4 cosine 7 point, I think it was 8. Plus, what was it, 1.4? And then let's find out the first time that this reaches 1.5 meters, which is right here, 0.234. Again, use your graphing calculator, equation solver, whatever. Okay, a camera is set to take a picture of the weight at a random time during the first 5 seconds of its motion. Find the probability that the height of the base is greater than 1.5 meters. Okay. So first, let me just shorten this to 5 seconds. Okay, so because it's like you're just trying to find the probability, so we need to find the time that it's above this weight, or above this height of 1.5, the total time, and then divide it by 5 seconds. So that means that you will need to figure out this time and figure out this time, and then multiply that by 6 to find the total time in 5 seconds that it's above 1.5 meters, and then divide that by 5 to get the probability that it's above that weight. So 572, right? So 6 times 0.572 minus 0.234, and then divide this by 5, and then you'll get some probability. So 0.572 minus 0.234 times 6 divided by 5. So 406, right? Okay. I'm slightly over 1 hour, and there are probably 2 more long questions. Okay. Drawing 2 balls out of a box without replacement. Okay. So they're dependent. You got R and Y. PYY is drawing 2 yellow balls. Okay. You know PYY is 1/3. Then you need to show this equation. Okay. So you need to find a way to relate R and Y together, and the only thing you really know is that the probabilities of each outcome or each of the sample space is 1. So let me just make a table real quick. So you could have red, red. You could have red, yellow, or yellow, red. Actually, let's do this as different ones. And then you have yellow, yellow. And you know that this is 1/3. And then we will have expressions for the other ones. Very ugly expressions, but okay. The probability that you're red first is red divided by the total marbles or balls multiplied by the next red, which is r minus 1, and then r plus y minus 1. And then these two will be the same thing. So you got red plus y times y, red plus y minus 1. And then this one is more or less the same thing, except you switch the r and the y. Not that it ultimately matters because it's multiplication. Okay, and then you know that if you add all of these probabilities together, it should equal to 1. And then I think you just need to manipulate it and you'll end up here eventually. Oh my god, okay. I hate these algebra manipulation questions. So I'm adding these two together, but they're both the same. So I'm just gonna write 2 r plus 1/3. So this needs to equal to 1, right? Okay, I'm gonna subtract the 1/3. So this is 2/3. And then I need to not have any denominators, so I'm gonna multiply this whole expression by a lot. So multiply it by 3 r plus y and r plus y minus 1. Okay, so cancel, this needs a 3, cancel, this one needs a 3, cancel, and then this one needs the r plus y and the r plus y minus 1. Okay, so what do I have so far? I'll have 3 times r minus 1 plus 6 times r times y plus 2 times r plus y times r plus y minus 1. Okay, let's see. Looks like I need to expand this out more. So this is 3r squared minus 3r plus 2ry. And then this is going to multiply out, so I'll get 2. What the heck? R squared plus ry minus r plus ry plus y squared minus y. Okay, and then I need to make it look like this. So I see the 2r squared and the 3r squared, and I need a minus r squared. So time 2, multiply the 2 in, and then move everything to the left side. And then write it in decreasing powers of y. Okay, so do I have a 2y squared? I do, right here. So 2y squared. And then I have a bunch of ry things as well, right? So I got ry times 2 is 4ry minus 6ry. So then this is minus 2ry. And then I have a minus 2y. And then I have a minus 2r plus 3r, so this is plus r, and then the minus r squared. Okay, and then I'm almost done, right? I basically, yeah, I just need to factor out the y and the 2 from this, and then you're done. So I'm not going to do that. I wasted too much time with that stupid combinatorics torts question. Okay, done. Easy-ish. Okay, solve this equation to show this. So this is a quadratic of y, right? This is like your a, this is your coefficient b, this is your c, and then you're just solving this equation as a quadratic of y using the quadratic formula. So here's a, this whole thing here's b, and then this whole thing is c. Okay, put in the quadratic formula, and you should get this. So negative b plus or minus square root of b squared. So I'm just going to square that right now. 4r squared plus 8r plus 4. So that's b squared. Minus 4 times a times c. So 4 times a, which is 2, is 8, and then I multiply that with c, which is r minus r squared. So minus 8r plus 8r squared divided by 2a, which is 4. Okay, let me simplify the square root part. So this part is going to become 12 r squared plus 4. Okay, that's nice. Okay, and then we can factor out the 4, and then when you square root it, you get the 2 on the outside, and then you're left with 3r squared plus 1, which I think is part of it, plus or minus 2r plus 1 over 4, and then these will reduce. Yeah, and then you're basically done. You ignore the negative because this is probably going to be a negative result, and y needs to be a positive number because it's about the number of yellow balls or whatever. Okay, there you go. Find two pairs of values r and y that satisfy this condition, y equals 1/3. Okay, so now that we know that this is the answer for y, right? We are going to find an equation using y and r, and then we'll substitute y with this expression and make that equal to 1/3 and probably solve that. So pyy is y, r plus y times y minus 1, r plus y minus 1. And this needs to equal to 1/3. And then we are going to take this y, put it in this expression, and then solve for y. That's really gross. But luckily, you can just use an equation solver, right? So put these in right here, equal to 1/3, solve the equation. Okay. Not gonna lie, that's kind of disgusting. So I am going to go to Wolfram. So what the heck was y again? I think it was r plus 1 plus square root r. Actually, I'll use x. Was it minus 1? Plus 1, okay. Okay, square rooted, so I'm just going to write that to the power 1/2. And then this I'm going to divide by 2, right? Oh my god, okay, so this is y. I'm gonna copy it. Then I need to put in this expression and ask it to solve it. So 2 y marbles, right? So y divided by r plus y, so r plus whatever this stuff is, right? I'm sure there's a way that you can simplify it and it might be a little bit nicer, but I don't really care right now. Okay, that's y minus 1 divided by r plus y minus 1. This is equal to 1 over 3. Oh shoot, I should not have r's, I should have x's. Okay, and then I wanted to solve. Come on, Wolfram. Give me 2 answers. You couldn't do it for me, huh? Where's my music? Do I need to simplify this for Wolfram? No, please don't make me do this. I don't want to work algebraically to do this. It's only 4 marks too. Fine, Wolfram. I will do this myself using Desmos. Okay, y equals 1/3. Oh, it's not possible. What? Hold on. You don't look right. Okay, apparently Wolfram could not do that, so instead I'm going to graph this expression and find out when its value is 1/3. Which is everywhere? Uh-oh. this not the equation I'm supposed to use? Well, y and r have to be integers, so maybe I can just graph this. Okay, so y is related to r like this. Yeah, this seems easier. And then we just need to find integer values, right? Oh, actually, let me use a table function. So you should be able to do this on your table. Hello? What do you mean too many variables? Y equals. No? Okay. This is gonna be super annoying, but you need to find out where along this you have two pairs of integer values, because r and y are about the number of balls or whatever. So, for example, here's one, 4, 6. So you could have 4 red balls and 6 yellow balls. I think I saw one earlier, maybe? I don't know. You should be able to use your table function. 1 and 2. So you can have 1 red ball and 2 yellow balls, but that doesn't make sense because you need at least 2 red balls. So we are gonna move along the line until we find the next one. I know there's one more question after this. This should work though, so I don't know why this doesn't work. But I've never used the Desmos table function, so... But there should be a way to do this in the table function of your graphing calculator. X plus 1. X n plus 1. X1? Oh, and you call it X1. Oh my god. Okay. It's okay. It's okay. X1. X1. Hello? There you go. 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15. Oh my goodness. Okay, sorry for that. But there should be a table function where you can, input a thing of x's and then write the relation with y. And then as you can see, we want integer pairs, and you can't use the first one because, like I said, this would correspond to 1 red marble, but you need at least 2. So 15 and 21. Oh, God. Well, that was dumb of me, doing it the first way. Sorry. Okay. Let triple y represent that. Find an expression in terms of y. Wait, so p, y, y, y. That's y, y1, y2, dot. Okay, -2, -1, r plus y, r plus y, r plus y. But it says in terms of y. It doesn't say in terms of r. Oh, here. Because now you know there's 10 balls. Okay. Okay, goodbye, goodbye, goodbye. Read the question. Read the question. Okay, then you add a yellow ball, so now it's +1. The probability of drawing 3 yellow balls is now twice the probability expressed in part D. Find the number of yellow balls in the box. Okay, so this is part D. And then you add one more stupid ball. So now it's y plus 1 is the first chance of getting yellow ball, y, and then y minus 1. Tired of this question. And then now this will be 11y. 11y minus 1, 11y minus 2. And then this is twice the probability of the one in part D. So this is equal to twice this probability here. Okay, let's see. There's gonna be some cancellation. So this is 10 plus y. This is 9 plus y. This is 9 plus y. 8 plus y. Okay. Goodbye, 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 goodbye. So we need to solve y plus 1 equals 11, y whatever 2, y minus 2 over a plus y. Okay, solve. Okay. Okay, I apologize, Wolfram Alpha, because I was not using you appropriately. Four. I'm done with this question. Don't like it. But mostly because of my mistakes. Okay, last one. Oh my god, this does not look fun. Okay, consider the differential equation. Y is 2 and x is 1. Use Euler's method. Okay. Step length 1. Find the approximate value when 1.1? Wait, that's only one step. I mean, it's only worth 2 marks. Okay, so Euler's method. Xn plus 1 is equal to yn plus your function, which is the derivative in terms of y and x times your step. But we're only doing one step, so this should be pretty straightforward. 2 plus, and then we need to plug in need to plug in 2 and 1 into here. So I get 1 plus 2 squared 12, which is 13, over 1 times 2, which is 13 over 2. Okay, 13 over 2, and then the step length is 0.1. Okay. What do I get? That wasn't that bad. Okay, 2.65. Okay. Then we're gonna solve the differential equation. Oh no. Okay. In the curriculum, you really only know 3 ways, I think. There's separable, there's the integrating factor one, and then there's the one where you can have like y divided by x. You can write the function as y divided by x or something. So if you just take a look at this one looks like the y divided by x one, which is, I think, called homogeneous, right? So I'm going to write this derivative as a function of y over x. So I'm going to first split this up. And it should simplify. So here I have an x over y, that's fine. And then this one I have my y over x, so that's nice. And then we make some sort of substitution. I think we say v is y over x, which means that y is v times x, so dy by dx is going to be this thing, so that's dv dx times x plus v. Okay, and then now we can just substitute all of these in. So now I have x times dv dx plus v on the left side, and then on the other side I have basically the reciprocal of v plus 3v. Now, this becomes a separable equation because your variables x and v are no longer in the same term. So first, man, they keep choosing the ones that I'm bad at. So combinatorics I'm bad at, and differential equations I'm bad at. Okay, and then separate. So then we will have 1 over, actually no, before I do that, let's make this side look better. This is v squared plus 2v over, wait, no, 1 plus 2v squared over v. Because this is basically 1 over v, and then we do a common denominator like that, and then now we can separate. So you're gonna divide the x over to this side, this divides over to that side, and multiply the dx over here. So you're left with v over 1 plus 2v squared dv equals 1 over x dx. And then now we can integrate. Okay, and then this needs a u substitution. So du is what, 4v? Okay, so this becomes 1 over 4 natural log 1 plus 2v squared, and then this is equal to natural log x plus c. Okay. And then you find out what c is. So do I have initial conditions? I did, right? This one? So x is 1, y is 2, which also means that v, which is y over x, is 2. So now I got 1 over 4 natural log of 2 squared natural log of 9 natural log of 1 plus c. Okay. This is 0. So c and then I'll just make this look nicer. I'll use log laws to do that. So c is the natural log of the 4th root of 9. Okay. And then we need to solve this equation with this being the 4th root of 9. Okay. Oh, and then we need to solve for y. So let me change this back into y over x. Okay, we're gonna solve this log equation. I'm gonna combine these guys together over here. I'm gonna raise this over here. Because now that I have natural log equals another natural log, I can just say that these are equal to each other. And then solve for y. So raise everything to the power of 4. So you get 1, oh wait, there's a square here. Okay, that becomes 9. This becomes the 4th root of x, which is part of, I think, what I'm trying to show. And then 2 y over x squared, 9, 4th root of x minus 1 divided by 2, square root it, and then multiply by x, right? Then that gives you y. Y has to be positive, so when you square root, you don't need to consider the negative one. Oh, sorry, not 4th root of x, x to the power of 4. There you go. Done. Solved. Find the value of y when x is 1.1. So plug in 1.1 into here. So 1.1 times 9 times 1.1 to the power of 4 minus 1 bracket. I need more brackets, whatever. Okay. I need to square root this. And then I need to divide this by 2, or technically the square root of 2. So 2.71. And then we did an approximation, so we're decently close. We're a little bit over, or the approximation's a little bit under. Okay, with reference to the concavity of the graph, explain why the value in part C is greater than the value found in part A. Okay. Oh, this is straightforward. We had a harder version of this question in Times on C actually. Okay, the reason why the actual value of y is greater than the actual value of the approximation is because of the way Newton's method works. If your function is concave up, Newton's method will always be an under approximation because the tangent line is always going to be below the function itself. So that's why they're saying reference to concavity. I bet you if you graph this, it's going to be concave up between 1 to 1.1. Decimals. Okay, x square root 9x to the power of 4 minus 1 divided by 2, and then again only interested between 1 and 1.1. Okay, so as you can see, well, maybe it's a bit hard to see because of the scale of things. So 1, 2, 1.1. To 2.8. Okay, this is concave up. I don't know. It's only two marks, but you could also take the derivative again. I really wouldn't do that for 2 marks, and then plug in your values, and then you'll see, you know, it's a positive second derivative. But either way, concave up, Newton's method, under approximation. 2 marks, whatever. I need to hurry up. I'm almost at 2 hours. I spent too long on those stupid questions. Okay, this is your graph. It has an inflection point at P. By sketching the graph of an appropriate derivative of y, determine the coordinate of P. Okay, derivative of y. So we're taking the derivative of this thing. Okay, time for a product rule. So derivative of x times the square root plus the derivative of the square root times x. So derivative of the inside, because we have the chain rule, what the heck would it be? 36 over 2 x cubed times the x from the product rule and then whatever, you just need to do this so that you can graph it, because they want you to sketch a graph of this. So now, I'm gonna be cheap though. Call this f of x, and then Desmos can graph f prime of x. Okay. From root 3 to 1. So we can adjust our domain here, just like you can in a GDC. Okay, make this sketch, include this minimum value, because that is where the inflection point is. Because an inflection point is where the second derivative is 0. The second derivative being 0 means that that is a local minimum for the first derivative, so here. And what did I need to do? Find the x-coordinate of p, so 656. So whoop. And then x is 656. Again, use a graphing calculator, find the minimum. Almost there. I need to be done with this, because I still have a paper 3. Oh my god, and this one's 6 marks. Okay, it can be shown that this is the second derivative. Use this expression to show that point P lies on a straight line with mx, where the exact value of m is to be determined. Okay? Okay. So point P is the point on the original graph, right? And then you want to show that this lies on a straight line. Okay, hold on. Let me... What was it? 0.656? Okay, here's point P. And then they're saying that we need to find the slope of a line, or a gradient of a line that goes through point P and also goes through the origin. The y-intercept is 0. So they want you to find m. But isn't that just, if it goes through the origin, then isn't that just the y value divided by the x value? So you just need to find the y value of this, right? Wait, but I didn't even use the second derivative. Copy. Okay, whatever. We're just gonna... Okay. This is at P, right? So I know that this is equal to 0, which means that this doesn't matter, so I have that. So I have 6y to the power of 4 plus x to the power 2, y to the power 2 minus x to the power of 4 equals 0. And then, what am I supposed to do? Solve for y, right? Because I need to basically do this. Okay. Okay, this is a little hard to see, but this is factorable, I think. with x squared and x squared. And then, what is this, 1, right? So 3 and 2. 3y squared, 2y squared. This needs to be a plus, this needs to be a minus. So then we have two equations, two solutions for this. 3y squared minus x squared equals 0. So y squared is equal to 1 over 3x squared, or this one here. 2y squared plus x squared equals 0. So y squared is equal to negative 1/2 x squared. And then this one doesn't have a solution. Because you cannot have something be squared and then have it be equal to a negative value. So no solution here. And then from here, we have y equal to the square root of 1 over 3, plus or minus. And then I think we only want the positive one because the y value is positive there. So this should be m. And I think that's it. I'm done. Okay, a little rough. I don't even know if I finished in time. Probably. Okay. A little rough. A little rough. This one actually wasn't that bad. Which one did I not like? Okay, I just was stupid here with this one. So do not solve this. Do not solve this. Right? You have a relationship between r and y. This is already like it's guaranteed to be 1/3, which is why when I did it the first way, it didn't work out. And you just need to find integer values that satisfy this. This combinatorics one, ugh, that's so bad. And then the rest are pretty straightforward, to be honest. Okay. Slightly easier than the first paper. I just made a couple of hiccups along the way. But yeah, still difficult, I would say. Still difficult. Well, thanks for listening. Hopefully this was good. A little sloppy today, but whatever. See you for paper 3.